All right, so 2.7 is on combining functions. This first video is going to be on just kind of the basic arithmetic, I guess you could say, functions. So talking about adding or subtracting or multiplying or dividing. And I think when you add functions or subtract or any of these, I would think it kind of works just the way you would think it would work. Meaning, looking at this table, we have f plus g of x. So we're adding f and g. All we're doing is adding f of x plus g of x, and likewise for the rest of them. So this is nothing too complex as far as, you know, I feel like it's pretty common sense. The algebra of it could get complicated a little bit, but um, I don't think it's too much to worry about. And then as far as the domain goes, it's basically, this means and, so it's all of the numbers that would be in the domain of f and also in the domain of b. So whatever is included in both of those, that would be the domain of the combination. And then the only exception would be with division. You cannot have 0 on the bottom. So wherever g of x is 0, then we have to exclude that. So let's look at a couple of examples, and we'll just kind of do one of each of these for now, and then and these could get a little bit more complicated. Like if you have two rational functions and you're multiplying or dividing, or you're adding and subtracting, obviously those get a little bit more tedious to do, but the same idea applies. You just have to be a little bit careful when you're doing the algebra, but hopefully know how to do that. If not, that's something we can work on. So let's start with just doing the addition. So f plus g of x. So f plus g, and I won't write this line, but we're essentially writing f of x plus g of x. So 1 over x minus 2 plus square root of x. And possibly that might be good enough. I don't know if you need to find a common denominator. In fact, I would say probably not. Probably we could just leave it like this. I don't think it gets any simpler than this. I mean, we could write it as one term, but I don't think that simplifies the matter very much. Same thing with this. So this is just the same thing, except we are subtracting. Then the multiplication, f times g of x. This would be 1 over x minus 2 times square root of x. And so you really just put the square root of x on top, because when you multiply fractions, which this is square root of x over 1, we're just multiplying across the top, so 1 times square root of x, and then across the bottom, x minus 2 times 1. And so we end up with that. And then the last one, division. So f divided by g of x. This would be 1 over x minus 2, and we'll put that in parentheses. That's our numerator, over the square root of x. Now, this is something you certainly want to be able to do pretty easily, is simplify a complex fraction like that. I guess it is a complex fraction, technically. So when you divide fractions, so let's say you're dividing a divided by b divided by c divided by d. Remember, you turn it into multiplication and you flip the denominator. And so that's how you divide fractions. So with this, we have square root of x over 1. So if we write that as multiplication, that becomes, we're going to flip this one as we're bringing it around, and we have that. Now, hopefully, when you see 1 over x minus 2 divided by square root of x, it'd be good to get to the point where you don't need to write this step. You can just put square root of x right there. Like, that goes in the denominator, and it's x minus 2 times square root of x. But if you need this extra step, that's fine as well. It doesn't add too much time to process here. Okay, so there are the parts to this. Now let's talk about the domains. So it's important to, essentially we need to find the domain of f find the domain of G, and then wherever both of those are. So these are all going to be the same. This one might be a little bit different. So the domain of F, this bottom part cannot be 0. So we need to take out 2. So the domain of F, we'll kind of write these up here. So negative infinity to 2 union 2 to infinity. So we just need to remove the number 2 from the number line, and everything else works. And then with square root of x, of course, that one is 0 to infinity. So now what numbers are included in both of these? Well, obviously 0 to infinity is there. This one has some negative numbers, so we need to get rid of all the negative numbers, but we also need to get rid of 2. So the domain, all of these will be the same. So we'll just kind of put this here. So 0, obviously we can't have anything before 0 because it won't work with square root. We're going to go up to 2 because we got to take out 2. Parentheses, union, and then 2 to infinity. And then that is our domain for these 3. And then this one is a little bit different, although not much. We still have kind of the same. We can't have 2, but now we can have 0 as well. So really, this domain for the division is going to be the same as this one, but we need to remove this 0. So this domain will be just parentheses with a 0, and then the rest is the same. So with the division, you always have to consider where is the denominator 0, but we kind of had to do that anyway with all of this. Okay, so again, it doesn't get any more complicated than that. Well, it might get a little bit more complicated than that, but the process is the same. The rest, any complexity that's added would just be adding algebra. So just you have more complex thing to simplify, but the idea is the same. Whatever f of x is, whatever g of x is, combine them in whatever operation we're looking at. So nothing too hard. We'll look at compositions in the next video, and that gets maybe a little bit trickier, but we'll see.